Yes, sir. Let's start. First, let's take introduction. Write some basic notes. Python is an open source language. And is a script-based language. With groups and functional programming features. Python can be used for network applications, production automation scripts, desktop applications, web applications, and data analytics and data science and artificial intelligence. Artificial intelligence. But our purpose is not the network applications or desktop or website applications. Our purpose is data science orientation. So for this, the base for Python programming and programming structures you need. And after that, you need special modules of the Python, which are used for this data science and machine learning. Okay. Write the statement. Python has different open source modules. Nothing, sir. Here in Java, you call it as package, but here the same thing is called module. Okay. Python has different open source modules for different purposes. Following modules are used for data science. NumPy, SciPy, scikit-learn, scikit-image, TensorFlow. Of Suppose this is a third party, not from basic Python community, the two by Google. Similar to Java has packages, right? Similar to here module. Okay. Pandas, Keras, NLTK, Matplotlib, TextBlob. This is third party again. I don't know the community name, etc. First, put the heading NumPy. Say numerical Python. Use it for linear algebra. Because most of machine learning models are matrix based or matrix based. NumPy has predefined operations, operators, and functions. To implement matrix based computations. Example, matrix multiplication, transpose, inverse, eigenvalues and vectors, etc. NumPy supports unlimited number of dimensions. Unlimited number of dimensions, dimensional arrays, just write like this, dimensional arrays. The two-dimensional array is called matrix. So that means not only two dimensions, sir, you can make like a 3 dimension, 4 dimension. In this unlimited number of dimensions you can make. Okay. Most of data preparation. Most of data preparation. Of machine learning models is done by NumPy. Our majority of work with all the models will be with NumPy. Okay. Suppose if I don't use Python, if I ask you like a 10 by 10 matrix inverse, you need to write a biggest code in the Python. But if I embed this Python library, that is just a statement. For example, I have defined A as one matrix, A dot of B. Automatically matrix multiplication will happen. Need not write any complicated code. Same thing in case of R language, what you are doing, A percentage star, percentage B. Similar to that. Okay? Hmm? We need to import it. Yes, we need to import it. So these are special modules. The next module is SciPy. Use it for statistical and mathematical modeling. SciPy provides predefined classes and functions for image and audio data processing. For image and audio data processing. The next module, I'm taking pandas. Pandas. Use it for data cleaning and data preparations. Data cleaning and data preparation. Before start trying the models, first you need to clean the data. So pandas, similar to data frames of your R language. Okay, it provides a easy mechanism to handle to manage our data. Okay. Next, Matplotlib. Use it for visualizations. Use it for visualizations. Next, scikit-learn. This is to train machine learning models. To train machine learning models. One simple example. Model equal to linear regression dot train input matrix and output matrix. Automatically you will get model fit. Model dot accuracy. Automatically gauges your accuracy. Model dot predict. In this way, it provides one special API. Select the model what you want to train. That model dot train. After that accuracy. After that prediction. You need not write any complicated coding for that. In machine learning, there are hundreds of models. For all the models, predefined class is available. SVM you want, SVM, S with name SVC, one predefined class will be there. Okay. Suppose dictionary you want, dictionary dot try. Of course, some models are expecting try method, some models are expecting fit method. So according to that, a fit, FIT. According to the documentation, what method they provided, you simply call that method. Okay. So, but you should have idea at what situation, what kind of model I should use. The library already available. Understanding these points. Anything, sir. For that purpose, one more thing. For another purpose, one more thing. For each and every purpose, one class is. Okay, the class has its own methods. We need to call the proper methods. Right? Yeah. Hmm? In R language also we have predict. Yeah. This one also predefined means it has some limitations. That's why you have to be a coder. To overcome that, you should develop your own function. For that, you need base program. Okay. Next. What is the next library? Let's go over scikit-image. Scikit-image. Use it for image processing. Advanced to SciPy image processing. Not only advanced, sir, advanced and simplified. SciPy image processing. Next. TensorFlow. To design computational graphs. You can say pipelines. Use it for deep learning. Have you heard about Google self-car driving? Google self-car driving is based on this TensorFlow, right? But this is purely the product of Google, sir. Non-license, open source. Theano. Same as TensorFlow. Same as TensorFlow. It's not model, module. Developed by Python community. Developed by Python community. Theano and TensorFlow. Both uses GPU computing. Tell you. GPU computing. GPU means graphical processing unit. Which increases computations speed. Because in deep learning, multiple layers networks will be involved. As input layer, hidden layer, output layer. Each layer has neurons. Each layer has hundreds of neurons. Here neuron means a array cell, you can say. At each layer, different complex transformations will happen. Different complex transformations will happen. The results will be passed to its next layer. Normal CPU computing systems. What we use CPU computing? So, normal CPU computing machines. Will take hours or days of time to process. Need GPU machines. Theano and TensorFlow triggers GPU for processing. Even nowadays, sir, every laptop is coming with a GPU. Of course, with a little capacity. Use capacity once means external GPU you need to embed. Graphics card. But even though GPU is available, if you run a program, your traditional program will use CPU. But these are using GPUs. Suppose one simple deep learning network I did. So nobody is listening, sir. I'm just busy into the writing. One simple deep learning neural network I just built it. If I have even 1 GB data, if you run a process, if you run it, tomorrow morning you will see the results. But no guarantee. Meanwhile, your laptop will be shut down. Again, when you switch on, again you need to restart the process. So for deep learning and all these things, our normal laptops are not working. Okay, you need to use GPU computing machines. But even though our laptop is having some inbuilt GPU, our traditional programmings cannot use that. In order to use GPU, a lot of complex networking code you need to build. Okay, you need to know how to maintain CPU caches, GPU caches, how to divide the multi-cores into the GPU cache. All these programming techniques you should have. Okay, but if I write something into Theano or TensorFlow, automatically it will take care internally. Every computation will be using that GPU. Automatically our process will become faster. Got it? So that's why previously all this, before TensorFlow, everything up to machine learning wise, they are okay. But once deep learning, advanced learning models came into the picture, previous models are not working. The R language up to how long the R language is up to statistics wise, R language is good. But for all the models of the machine learning and deep learning, Python is very good. Especially production application point of view. User is directly attacking with inputs. On the live application, you cannot engage your R language. So finally, you are training the model. Finally, once model got trained, where it is going to deploy itself into the production racks. Okay, at that time, the R kind of things are not worthy. Those are just LKG for our data sets. But R is not data science. Majority of our work is with Python, especially in the machine learning and deep learning. But when time comes to the deep learning, we need to use advanced models again, like the Google's TensorFlow or Theon. Like
How we are going to
hmm?
provide
Just to use Theon and TensorFlow automatically, inbuilt some GPU is there. The Theon and TensorFlow will enable them, but our traditional programs cannot enable them. Understand the point? So that will be taken care by this TensorFlow or Theon. Got it? So this is what simply. But writing code into Theano and TensorFlow, a little brain headache process. Instead of writing hundreds of lines into the TensorFlow, some high-level API is released. That is Keras, which makes your 100 lines of TensorFlow into 10 lines. Okay, that means Keras is a high-level API which runs on top of Theano and TensorFlow, so that you can easily develop your deep learning applications. That is what Keras. Okay. No, no, that is also purely third party. Third party. Still open source. Open source. Keras. Write down. Is a high level API which runs on top of Theano and TensorFlow. Theano and TensorFlow to build deep learning models. To build deep learning models. Similar to Keras. K sir. KE. TensorFlow Slim. TensorFlow Slim. Caffe. Third party modules are available. Third party modules are available. So different companies will use different things, but majority is with Keras. Okay. Next, any other model pending in our list? NLTK. NLTK. User for NLP. What is NLP, sir? Natural language processing. Right. Natural language processing. NLTK stands for Natural Language Toolkits. Natural Language Toolkit. use it to pre-processing of the text, unstructured text. Such as word tokenization, sentence tokenization, punctuation tokenization, semantization, lemmatization, parts of speech tags, extracting features from the text, etc. Sir, what do you mean by word tokenization, sir? Suppose I am giving a line. Just observe this, all of you. Simply in Python, you have a split function. No need to use any library to tokenize them. Simply I will say line dot split. I will get array. The array is W here. If space is delimiter, how many words are here? 4. 4 words will be into the W as a list. Suppose I love data and science. This is my words. How many things will be there? It will take 3 only. But some punctuation is added. Some other special symbol is added. Or else a data comma something. Now what base technique will delete? This entire thing has one single word, right? Now that has to be separated. Even though comma, it can be apostrophe, it can be some other thing. You have special things. Programmatically, not to divide such kind of things, you have to be mastered in regular expressions first. Understand the point, sir? That too, complex structures you cannot deal, even though you are expert, 2 years experience into the regular expressions also. Such kind of complicated expressions you need to use. Got it? But here in NLTK, for all tokenization required, you have predefined functions are available. Punctuation wise tokenization available, word wise tokenization available. Okay? And also sentence tokenization is also available. For example, from the given comment, if I quote some comment in the Twitter means, my comment will contain multiple statements or not. Generally, sir, observe this. Statement 1 dot statement 2 dot statement 3 dot statement 4. Now simple technique. If this is available in some line dot split, what is the delimiter, sir? Dot is the delimiter. This is general programming technique. But after first sentence question mark, second sentence question mark, third sentence some apostrophe symbol. Like this. If my data is like this, if I split it based on the dot, what will happen, sir? How many dots here? One dot. One dot means 2 sentences. Before dot as sentence 1, after dot remaining everything as sentence 2. But in fact, other things are there, right? In my paragraph, sentence to sentence, some sentences question mark, some sentence like semicolon. In this way, special symbols. Programmatically handling is very different. You have sentence tokenizers into the NLTK. Directly you can call them. Instead of using a traditional split function, if I use sentence tokenizer, suppose my sentence tokenizer will be like this. Sentence tokenizer. One tokenizer object I am creating. S equal to sentence tokenize. Object created. After that, I am saying that S dot tokenize. Tokenize of my variable. It doesn't matter whether it is a dot or question mark or apostrophe or some other thing like this. Automatically, that is divided into different sentences. Once sentence is derived, you can apply different word tokenization. Again, punctuation tokenize you want, general tokenization you want, what are the different varieties of tokenizations. Every tokenization is predefinedly available. And one more example, sir. Okay, here a lot of people are with the big data background. In our big data, in our Hadoop, your first hello world example is word count, sir. Okay? Observe this statement, sir. I love you. He loves me. We love. I am loving. If I apply some word cloud, that means some word count, what will happen, sir? Love as a separate word, right? This loves is a different word, right? This loving is a different word, right? How many times love is repeated, sir, here? Actually 4 times, but your word count program will say what, sir? 2 times. In a given article, love is highlighted more times means that is a story about the love, right? On that way, I want to label my article, label my novel. Understand the point, sir? But in the cloud building, what is happening? It is highlighting love as a small icon, but love as a big icon here. So where is the problem? Yes, here loving. This kind of process, converting your webs into the base forms. The process is called lemmatization. Understand the point, sir? Okay, sir. Eat, eat. Apply the word count, sir. What it will say? Eat has one time only. But eat is about here. Such kind of grammatical formats also analytically will understand, sir. Getting this point or not, sir? So what it is converting, each and every verb it is converting into base forms. That is what lemmatization. Semmatization means buser. What is the plural? Buses. You want to apply the same kind of format for the nouns, semmatization. For both nouns and verbs also you want to apply this one, lemmatization. Okay, for all these things programmatically how much tough it is. Analytica is providing library which makes the process easy. Lemmatization you want predefined function. Tokenization you want what kind of tokenization you want for that predefined function. Create an object for your class. That object has a method object dot method. Process work. Understand, sir? So that is the importance of library. But still NLTK, you need additional help. That is machine learning. What NLTK can do according to this example? Entire pre-processing only it is doing. Once the features are extracted, what is our last statement, sir? This is our last work in the NLTK. Once features are, before features are extracted, what is the work, sir, here? A lot of pre-processing, like tokenization, parts of speech tagging. Okay? What do you mean by parts of speech tagging, sir, here? I love to love. There are two loves are there. What is the first love? What is the second love? One love is acting as verb, another love is acting as noun. Understand, sir? Based on my sentence structure, automatically NLTK will understand parts of speech. Understand the points? Even though I don't know English, my NLTK, my library can understand these parts of speech. Got this? That is what parts of speech tagging. And majority of our work is with the semmatization and lemmatization. All these are the pre-processing for each and every word, if data is unstructured. Once all the pre-processing completed, extracting features from text. For example, one of the example, extracting features from the text. First statement, sir. Second statement, sir. The third statement. Let's say head, sir. Apply the sentiment, sir, for this. Sentiment positive. Second, positive. Next, let's say negative. This is the given data. Think that pre-processing is also completed. Once the pre-processing completed, what are all the unique columns are here? I love you, eat, because the lemmatization is already applied. That is a unique word, right? Eat, hate, dance. These are the things. Each and every word is acting as one column. Then I want label. Label is sentiment. Now observe this. How many unique words in the statement? In all the statements, how many unique words here? 1, 2, 3, 4, 5, 6. First word, I, available, sir. Next word. In the first sentence, love available or not? Available. You, available. Remaining things. 0, 0, 0. Then what is the sentiment? Positive. This is what feature extraction. There are different varieties of feature extraction techniques. In this way, do the same thing for second, sir. 0, 1, 1. Remaining things 0, 0, 0. Here it is 1. Still it is. What kind of statement it is? Positive statement. In this way, for each and every row, I need to convert this because all of your machine learning models based on the matrices. In the place of a matrix, if a text value, it cannot do computations, right? What is the eat star dancing, sir? Eat into dancing is what? It cannot do computation, right? You need feature. Extracting that feature. Okay, sir, this is the given data. Already you are expert into Java, you are expert into R and Python. Come on, write a code to convert like this. A big work is there for your brain or not? But in analytic, a predefined function. There are different varieties of feature extraction techniques. Suppose TF-IDF is one of the popular. If I call it text.tf-IDF, automatically the features will be extracted. But once the features are extracted, what is the next step? Up to now, only data is ready. Data is ready, but not your model acted trained, right? To train the model, what is required again? Machine learning model you need to use. Where are machine learning models? In which module? Scikit-learn. The scikit-learn purpose is what? To train your models, right? Once I prepare data, once I extracted features from this text, then I need to apply machine learning model. Scikit. Instead of taking analytic work and then machine learning work, instead of doing that work, if there is one model which can do both, which can extract the feature, which can train the model, if there is one more model, that is what? TextGlobe. Understand the point, sir? Suppose I am expecting based on the given statement of the user, whether the statement is positive sentiment or negative sentiment, I want to find out. Suppose you are saying that one comment, I am not interested in class. Positive or negative statement? Negative. That's it. If any new statement is given, automatically my application, I am expecting my model should predict it. Whether it is a positive sentiment or negative sentiment. For this, what I need to do? After all pre-processing, extract the features. Later, I need to apply some machine learning model. That means I am taking help of two separate disciplines, right? If there is one single module which can do both the things, my work will be simplified, right? That is what a text. Understand the points? Yeah. Take some basic examples. Already have taken this one, right? Parts of speech and extracting the features. Only for feature extraction, take one example. Online team, please, you also please take notes. All of you done? Take one more example for lemmatization. Lemmatization examples. Bus, buses, as bus. Eat, ate, eaten, as eat. That means converting words into base forms. Converting words into base forms. Okay. Once features are extracted from text, we need to train the model using scikit-learn. We need to train the model using scikit-learn. Instead of using both NLTK and scikit-learn, a single text block which is more simplified is used. A single text block module which is more simplified is used. Still any modules pending, sir? All are completed, right? Anything pending in our list? Matplotlib, already I told you. Visualization. NumPy, SciPy, scikit-learn, scikit-image. I told about scikit-image. TensorFlow, Piano. You are simple heading Python programming. Pardon? Text? That is what last statement. The last two lines about text block. Today, instead of using NLTK and scikit-learn combination, directly text. That is, the text block can do pre-processing, can extract the feature, and can train them out. Okay. Three things you get. Next. Two types of environments. One, script execution. Two, interactive shell. Script execution and interactive shell. The first one, save your code with .py extension. Example program 1 .py. Then execute. Suppose this is your command prompt. On the command prompt say Python, your script file. Use the interpreter, not compiler. Second is interactive shell. Just from the command prompt, say Python, enter. You will get a prompt like this. Whenever you say print C, the value will be getting. Suppose the output is like this. Statement by statement you can execute in an interactive way. Advantage of interactive mode. Advantage of interactive mode. Not debugging. Execution, statement by statement execution. Suppose 10 statements. Everything. 10 statements are there. Fourth statement there is error. It stops the process. So here advantage of interactive mode is, if you observe, lot of cases you might face this one. Whenever you see the task, by seeing the task you don't get any idea. Okay. If it is interactive mode, whenever I see the task, with my basic perception, I start my code. Step 1, step 2, step 3, step 4 done. After the step 4, I started what to do in the step 1. Once if I check the output of the step 4, I will get some clue what to do in the step 1. Again 5, 6, 7, 8, 9, 10. Again I started. Once if I check the 10th line output, I will get a clue what to do in the 11th. Statement by statement you can execute, you can check the output. That is what advantage of the interactive. So final benefit, complex logics can be defined easily. Complex logics can be defined easily. So this is what like the basic introduction to Python. But there are a lot of other modules like Django, in this way. All these are for website development. Our purpose is not that one. Our purpose is we need to learn the Python in data science orientation, right? Not only Python, sir. Python has packages, right? That means modules, right? These are also open source. Okay. But Python is available for almost all operating systems nowadays. Python for Windows, Python for Linux, Python for all Linux flavors, Palm OS, like this. Now, can I say Python as platform independent? No, because you need to download Python separately for Windows, Python separately for Linux. It is not a platform independent. Okay, but available for all platforms. Just add that point, sir. Conclusion. Python is not a platform independent. But available for all platforms. Okay, sir. Take a break, sir. So online team, take a break for 10 minutes. One more new link you will get, sir.